So let's start with the presentation. I have shared my screen. I think everyone is able to view these PPTs. So let's start with the presentation. So I'll ask you a question. What if I'll give you a computer system with internet connectivity and ask you to check whether your internet is working or not? Which site will you try to open? You can unmute yourself and answer me, or you can type whichever way you feel comfortable. Better will be if you'll unmute yourself and answer me. If I'll give you a computer system with internet connectivity and ask you to check if your internet is working or not, which site you will try to open?
Google.com.
Google.com. Anyone else? So why Google.com? Why
That is
not
the
any other site?
that is the most preferred search engine in the world.
Most useful search engine
Okay,
we are using right now.
okay. So we all have become so habitual with the, with the internet that we, whenever we have to search anything, we try to open google.com or let it be any search engine. Even when we have to search something on our mobile phone over the internet, we just go to directly to our Android phone and open the search option and type any query. That is also, we are indirectly connecting ourselves to google.com. Yeah, so that is the power of the search engine. We all have become so habitual with the search engine that whenever we have even have to check the internet connectivity, we try to open google.com. So there are some facts about these search engines, and I'm not talking about only Google. I'm talking about generalized search engine. Let them be Bing, Yahoo, or any search engine. Now the information over the world wide web is scattered, and finding the information from the search engine is like finding needle in a haystack, right? Because each and every site that is present over the internet has a numerous amount of information, right? So if I'll try to, journalize the thing and I try to determine the size of the world wide web, it is equivalent to the total number of words spoken by the entire human race so far, and written in just .txt format. That is somewhat equivalent to the size of the web, right? So think of the scenario. Whenever we are shooting a query, what we are trying to search, we are trying to search a textual file that contains the number of words which are spoken by the human race so far. And this is approximately equal to 1 yottabyte. That is one followed by so many zeros of bytes, right? Now there is a graph that I have presented, and this graph represent the part of the web that the search engine has indexed. Now whenever we are shooting any of the query, it is not like the search engine is going directly to the world wide web. It is just going to the index that it has created. So I think all of you know the meaning of the index. If I ask you in a book where the index is present, at the at the starting of the book or at the ending of the book, where the index is present?
Starting only,
At the
starting.
book.
Starting.
Ending of the book. At the
Ending.
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 Okay, so what is present at the starting of the book? That
Table
is
of
table of
contents.
content. Yeah, exactly. What is present at the end? That is the index. Index is directly which maps word with the page number, right? And similar is the thing with the search engine. They have the words that has been mapped with the website, then the URL. You all understand the meaning of URL. Whenever you are typing something in your browser, that is the uniform resource locator, that is the URL. So whenever you are shooting some keyword, whenever let us say I'm shooting coronavirus, the word which is this coronavirus will be mapped with some of the website, and those will be presented to my end, to my result end, right? So by 2000, the search engines have indexed around 35% of the world wide web. Around in 2005 they have indexed around 34, and in the latest data that was available was 2014, and they said that they have indexed 50% of the web. Now if I talk about that, I have indexed 50% of the web, that means I have visited 50% of the web. But do you think we can visit 50% of the web? Because by the time I will finish this presentation, so many new website will come into the picture. So many old website may get stale, and also those websites which are currently running might have information that has been updated by the administrator, right? Like if you talk about your own college website or your own university website, then the information present on that might get changed after a week or maybe after a month. But if I talk about a news website, the information that is present on that news website might get changed even after a minute or even after 30 seconds. So how the search engine will know this thing, that the information is getting changed so fast? And to determine the size of the web, we need to know the total amount of information that is present over the World Wide Web. And that is impossible to determine, because if I have taken a site into consideration, I have created an index of that particular website. By the time I will finish that process, that site might get changed, right? And all the processing that I have done may become useless, right? So this scenario that we were talking about, this percentage that we were talking about, assume that we know the size of the web, but we don't actually know the size of the web. It is just like a black hole. The information is getting so rapidly getting changed, or the information is getting added on, or the old information is getting deleted, that we can't determine the size of the web. So actually we are searching something, or you can say that the domain of the information that we are searching in is infinite. So we actually don't know the size of the web. So there are some more things about a search engine. So I will briefly tell you what a search engine is. Search engine is just a software system that is designed to search the information that is present over the World Wide Web. Let us take an example of Google. What's the functionality of Google? Google is just meant to find the information that is scattered over different websites present over World Wide Web. Now, a search engine actually has three main components. First is a web crawler, that will be our topic of interest. The second is an indexer, and third is an searching interface that is presented to the user. So we'll take this thing one by one. If you'll see this particular cloud, and let us say the complete world wide web, and these squares present in this orange cloud represent some of the web pages. Now these are the web pages which makes a world wide web, let us suppose. Now what the crawler will do, the crawler is actually a software program that will keep on running between these web pages and will bring these web pages at the local end. Now some of the web pages, let us say out of thousands of the web pages, it has chosen some of 200 or 100 web pages, and that has been downloaded at the local end. Now these at local end will now the main purpose of the crawler is to bring the web pages from the World Wide Web to the local end. And after bringing them to the local end, what it is doing, it is just creating a repository, or you can say it is creating an index. Now the index, the main meaning of the index, or the main functionality of the index is, whenever a user is shooting a query to the search engine, those queries can be handled very easily. As I'm talking about the index that is present at the end of the book, whenever you are shooting some query, what keyword matching technique is performed? The keyword matching just matches the keywords that are present at the back end of the of the book, and after matching those keywords, we just give you directly the web pages that where the information is present. Now coming to the next slide, the main role of a web crawler. Actually, you can say that the web crawler is the heart of any search engine. Reason being, because it is going to get the information that is present on the World Wide Web, and as much information that the crawler has fetched from the World Wide Web, that will act as the domain of the web crawler. Now this web crawler can copy all the pages that it is visiting and can index it. But because the amount of information that is present on the World Wide Web is very large, the crawler cannot visit each and every web page that is present over the World Wide Web. Now if I let us suppose, if I have thousands of web pages, my crawler needs to visit each and every page, right, and needs to download it, and bring it to the local site. And after bringing it to the local site, what it needs to do, it needs to extract the keywords from that website and create an index of the same. Now, by the time the crawler has, downloaded a web page, created an index of the web page, it might happen that the web page information might get changed. And if that is happening, the crawler needs to visit that web page again download it to the local, and again create an index, and then again, wait for the the end user to shoot the query, so that that web page can be returned in the result. But these things need to be prioritized. How efficient my search engine is depends on the crawling strategy, right? So if we think that Google knows everything, that is a misnomer. Google doesn't know everything. Google knows only those things which its crawler has visited, has downloaded, and has indexed at the backend. Right? There might be some web pages that Google is not aware of, or the Google crawler has not visited, and then those web pages will never ever come into the result of a search engine. You must have heard the name of search engine optimization. What we do in SEO, we lure the web crawler so that it comes to our local and download those web pages so that they can be indexed by the search engine, so that whenever some user is shooting some query, our web page will come in the topmost result, right? So these are the things that keep on working at the back end so that a search engine can work efficiently. Now I will talk about the journalized search engine, and it will give you an overview of what our web crawler program looks like. So uh, the crawling process whenever we start the crawling process, we start it from a seed URL. So what is a seed URL? A seed URL is actually a URL from where we will start the crawling process, because we have to start from somewhere. Now, World Wide Web is an open thing. Now, let us suppose I am starting from your college website. So if I'm starting from pec.ac.in, that will be acting as my seed URL. So if I'm interested in, let us say, on all the educational website or on all the universities or colleges of India, then my seed URL will be some of the universities from where I'm going to start the crawling process. So let us suppose this seed URL for the time being is, let us say, pec.ac.in, from where I'm starting the crawling process. Now, after passing the seed URL, there will be a multi-threaded downloader. Now, the purpose of the multi-threaded downloader will be to download the web pages from pec.ac.in to the local machine. Why I'm using multi-threading? This is again a different concept, just to, so that my speed can be maximized for doing all those things. I'm using a multi-threaded downloader. Now, this multi-threaded downloader will do two things. First thing, it will scrap the URL from the page. Now, if you will see your university homepage, you will observe two things: that there is textual information that is present in your website, and there are some links that are present in your website homepage. Those website homepage, those links are those those inform or those data where you can click and you can reach to other web page. And if you view the source code of that web page, that will be present under ahref, right? That thing is clear, I guess, that whenever we have visited a page, and if I want to further go to next page, I need to click to some of the URL that is present on that web page. So the first thing the multi-threaded downloader will do, it will separate the text and separate the link from those the web page. If I'll talk about your again your college website, your college home page, it might further contains the link for the different departments, for the different faculty members, for the syllabi, for the timetable, etc. So it will scrap all the URLs from that web page, and the next thing the crawler will do, and those URLs again will be added to a queue of the URLs to be visited further. So if I'll think of this thing that I have started from pec.ac.in, I have added pec.ac.in slash faculty slash syllabi slash something to my URLs to be visited further. Now again this URL added to the queue will be managed by a scheduler. Like in operating system, we have short-term scheduler, mid-term scheduler, long-term scheduler. Here we also have a scheduler that will choose some of the, some of the URL from the list of the URLs and then pass that URL to the multi-threaded downloader. Now, this process is getting repeated again and again. And this multi-threaded downloader is again downloading the data, passing the URL further, then URL are getting added to the queue, then scheduler is choosing one of the URL, passing it to the multi-threaded downloader, and this process is getting repeated again and again. Now, tell me, what will be the stopping criteria? If I'm passing this thing to a crawler, I have started from pec.ac.in, when my crawler will stop? Otherwise, it will be a never-ending process. Getting my point? If I started from pec.ac.in, I have started the crawling process. What will be the criteria, and after which particular interval of time my crawler will stop? Because this is going to be a never-ending process. Because my pec.ac.in might contain links to YouTube, might contains link to Facebook, might contain links to other website or other educational website. So my crawler will go further to those website and it will start crawling them as well. So what will be the stopping criteria when my program will stop collecting the web pages? Anyone? You can type or you can unmute yourself to answer. What will be the stopping criteria when my crawler has started the crawling process and when it will
The queue becomes empty.
the queue becomes empty? Do you think at any time the queue may become empty? Because if I have started from any website, can you think of any web page in your university website that does not contain any href link? I don't think there will be any web page in your university website that doesn't contain further links. Until no web page has no web links. That is the thing I'm telling you. I don't think there will be any web page in your university website that will not contain any link. At least there will be home link. It will be pointing to the home link. Shutdown of the system. No. Again, it is going to be a never-ending process. So what you have to yourself tell the crawler when to stop. So for doing this, what I can do, let us say I can specify the limit on the crawler. For that, what I can do, I can specify that if my starting URL, my seed URL was pec.ac.in, then you are not allowed to move out of pec.ac.in. If you are getting a link of YouTube, just discard it. If you are getting a link of Facebook, discard it. Because otherwise once I will reach to facebook.com, once I'll reach to youtube.com, I'll again start downloading the web pages from Facebook and YouTube, and again it will become a never-ending process, right? Again, if you want to specify some limit on the crawling process, you can specify that if you have started from pec.ac.in, then you are allowed to go only 5 depth, or you can say 4 depth. That means 4 depth means pec.ac.in /faculty /something. That is 4 depth, right? That means after 4th depth, you will not allow your crawler to go to the 5th depth. So again, when you want your crawler to stop, it again depends on you. Otherwise, crawling is going to be a never ending process. So this scheduler will keep on getting the URLs. Again, it will keep on sending this. Now, if you can think, each and every web page of your website must contain a home link, which can again take you to your home web page. So if this is going to be thing, what will happen, that again and again you are getting same link, again and again you are visiting that thing, So you should also maintain some of the data structure that can keep a check of the URLs that I have visited once and I need not to visit them again. Otherwise, you will be just wasting your resources, right? No. Now, the next thing, apart from security, what are the other challenges which are faced when I'm doing web crawling? I will be having different slides on security in web crawling. So what are the challenges? So the first challenge is the problem of big data. Now let us suppose if I just have 10 billion of web pages, and this is very small number, 10 billion of web pages, and assuming that each web page just contain 10 KB of data. Now it will require 100 TB of storage to index it, because I need to download each and every web page, bring it to my local site, download it, and then create an index. So just to create an index for 10 billion web pages, each of 10 KB, I require 10 TB, 100 TB of storage. Again, because web is growing at a very faster rate, it becomes very difficult to index each and every web page. Now there was no website related to coronavirus. Now there are so many websites related to coronavirus. I need to index each and everything which is related to coronavirus nowadays. So it has again created a new challenge for me. Each and every day a new terminology is coming, and again I need to search those websites for those particular terminology as well. Again, there is a very high resource requirement whenever I'm doing a crawling. Let us suppose if I have 100 machines, and again assuming I just have 10 billion of web pages. Now 100 machines which are crawling at 100 pages per second, it will require 11.6 days, assuming that I have a very high internet connectivity. So this internet connectivity, this machine requirement, machine processing requirement is very high. And I'm telling you these challenges because this was part of the work that we have done in our PEC Institute. I was during my PhD. I have worked on a government of India funded project, which was about collecting the information of all Indian origin academicians who are working outside India. And for that, there was only one option of doing crawling. And for doing that, we have all we have used different types of machines, different types of crawling strategies, and these were the challenges that were faced by us as well. Now the last challenge here is the problem of frequent updation. Problem of frequent updation means by the time you will finish crawling a website, that website might get changed. So by the time you will finish crawling NDTV website, the information on that particular website might get changed. But that will not be the case with your institute website. The information on your institute website might get changed after an hour, or sorry, after a week or after a month. But that is not the case for your for your news website. So your crawler has to decide when to visit which website. It needs to visit university website less frequently as compared to news website, right? So coming to the next slide, there are some policies, because whenever you are going to a particular website as a crawler, there are some policies that you need to follow. You have to be a good citizen of World Wide Web. Reason being, all the websites that are present over the internet are meant for legitimate user. They are not meant for the program that you have created. So if your program is visiting them again and again, you might hamper a website with the request, right? And mind it, there was a study that concludes that over the internet, around 40% of the traffic is just because of the web crawler, and that is not because of the legitimate user. Now think 40%, that is only just because of the web crawler. It's a huge number, right? So I need to handle these things very in a very effective way. So whenever your program or your web crawler is visiting a website, you need to follow these policies. First is the politeness policies. Politeness policy means you need not to hamper any website with the request. If you keep on sending the request to a particular website again and again, what it will do, it will block your IP address. It will block your program. And again, each website has a robot.txt. I will explain this in the next slide. That robot.txt is the security concern of any website. If I want that these particular web pages should be visited only by a user and not by any program or a crawler, I will specify them in the robot.txt. And if any of the crawler is trying to visit it, then that robot.txt, I can take any action against them. And any crawler should only visit those websites which are allowed by the administrator. Now the next thing is robustness policy. Robustness policy means my program, my crawler should be immune to the traps. Traps means you must have visited some of the web page that has a link at the top. Wherever when you will click that link, that will take you to the bottom of the website, and when you will click at the top link that is present, it will take you to the top of the link, right? This top bottom thing will keep on fluctuating you on a single page. So your crawler should be immune to such traps. Now the next is parallelization policy. Parallelization policy, that whenever you are visiting a website, now you might contain multi-threading. Now whenever you are doing multi-threading, it might happen that your multiple threads are visiting same web page. It should not happen. There should be a centralized controller that is trying to download different websites at the same time. Otherwise you are just wasting your resources and time. The next thing is revisit policy. Revisit policy is, if you want, there are two trade-offs. There is or you can say there is a trade-off between whether you want to expand or you want to visit number of web pages, or you just want to visit a few web pages and want to keep them up to date. So it is completely on the admin whether you want to check for changes again and again after a certain interval of time, or if you want to cover too much. If you have covered, let us say, thousands of web pages and you are not revisiting them, then those all 1,000 web pages might get stale after a week or so. But if you want to just visit 100 web pages and you want to keep them up to date in your database, then you will be visiting them again and again, right? So it completely depends on you how you want to handle the things. Now coming to the security aspect of the web crawler. So whenever you are visiting any website, the first thing that you should do is to open the robots.txt file of that particular website. And mind it, in Indian scenario, 90% of the website does not have any robot.txt. And if you want to try, just type the name of your website /robot.txt, then you will be able to see whether your particular website has robot.txt or not. So our college also does not have any robot.txt. So what's the meaning of robot.txt? Whenever any crawler is visiting your college or your website that you want to crawl, the first thing that it should do is to open this robot.txt. What this robot.txt contains? It contains the name or the links which you are allowed to crawl, and also those links which you are not allowed to crawl. Like this is the robot.txt for apple.com. This apple.com means the first thing is user agent. User agent means the name of the crawlers to whom you want to give the permission. If I have just specified star, that means all. That means this is the rule that I am making for all the crawlers. That is, user agent means star means all the crawlers. Disallow. Disallow means I will specify the URLs in apple.com where I don't want any crawler to go. Now I haven't specified any means any website name. That means all the crawlers can go anywhere, right? So user agent star means all crawlers. Disallow means the link of those or those part of the apple.com where you don't want any crawler to go. As I haven't specified anything here, that means any crawler can go anywhere. Again, this is the robot.txt for microsoft.com. Now again, this user agent star means all the crawlers. All the crawlers disallowed and at these particular URLs. Now mind it, these URLs are not complete. That means that they needs to be added in front. This Microsoft.com needs to be added in the front of these URLs so that you can get the full URL, right? So this represent that all the crawlers are not allowed to visit these links. Now tell me, if you will try to visit these links and you are not following robot.txt and you are not a good citizen of World Wide Web, what will happen? If you have designed a crawler, you have designed a program, to be very honest, designing a simple crawler in Python is just 7 or 8 line of code, right? So it is not a scam if you try to visit these particular URLs that your robot.txt file is not allowing you to do. So what will happen if your crawler will try to visit these websites? Anyone? So this was happening with us as well. We were not initially following the robot.txt and we were trying to visit the all the links without looking at the robot.txt. And what was happening, that after a certain interval of time our IP was getting blocked, because any server can very easily distinguish whether a web page is being visited by a legitimate user or it is being visited by any program or any crawler. So if they will come to know that any particular link is being visited by the crawler again and again, even if it is listed in the robot.txt, what it will do, it will consider it as an unauthorized access, and what it will do, it will block those IP addresses. So it was happening with us as well. If we are not following, it will be blocking our IP address. Now this is again the robot.txt for springer.com. This contains user agent. This is the name of, now mind it that each and every crawler or every famous crawler has its associated name. That is the introduction it needs to give to the server whenever it is going to visit that particular website. So here I have specified user agent Googlebot. That means Google crawler is allowed everywhere except in these particular links, right? So Googlebot, that is the Google crawler, it is allowed everywhere except in these particular path that I have specified. Again, user agent Slurp, again user agent MSN bot. Now if I'll talk about Slurp and MSN bot, they are allowed everywhere because in the disallow I haven't added any particular thing. Now the scroll delay 2 means that between two consecutive requests, there should be a delay of 2 seconds. You can't hamper those particular server with requests. So if you will try to send the request again and again and you haven't kept 2 seconds of time difference between two requests, what it will do, it will block your IP address. Now again, this scooter is the search engine, or you can say the crawler for Alta Vista. For Alta Vista, what it has done, it has disallowed nothing. That means a scooter is allowed to go and visit each and every web page that is present on the Springer, and for all other which are not listed above, they are disallowed. Now this means that they can't go after this particular home page, right? So you can specify any particular web page, you can specify the full website as well. So by keeping if you want to think, if you want to keep some data over your internet or over your website as secure data, what you need to do, you need to specify in your robot.txt the sites or the links or the web pages that are allowed to be visited, and also you can specify those links which are not allowed to be visited, and after that no one will be allowed to visit those web pages. And if they will try to do so, what your system can do, you can block the IP address directly. Now coming to the next thing, if you'll see this particular picture, there are two types of fishes. First, black fishes, and then there are some orange and yellow fishes as well, and there are two boats. One is orange boat and the other one is yellow boat. Now this yellow boat has some threads which are connecting directly to the yellow fishes. In the similar way, the orange boat has some links which are directly connecting to the orange fishes. Now, this consider this yellow boat as a particular website. Now, this particular website contain these particular yellow web pages. In the similar way, this orange website contains some pages which are directly linked with these orange pages. Now, there are some black fishes as well. Now, these black fishes are not directly connected to any of the bot, or you can say to any of this particular website. And these part of the web which is not accessible by following the hyperlink, or you can say which is not directly connected to any of the link, is considered as hidden web or deep web. Now, the web or the World Wide Web basically can be divided into three parts. The first one is the surface web. Surface web is the web that we all have been using from so many years, that contains those web pages which are directly connected with each other. So that is the surface web. The second part is the deep web, the thing which I am discussing here. Deep web means uh, that part of the web which is not directly accessible by following the hyperlink. You can't directly access them by by clicking on the links, because there is no direct link present on them. And the third part, or the third part of the web, is the dark web. That has not been specified here. The dark web is actually that part of the web where all unauthorized activities related to illegal smuggling, porn, all those things which are present in the dark web. And the dark web, you can say, is the part of the deep web where all the unauthorized activities are happening. Now the thing is, if we have surface web, why we are so much interested in dark web or deep web or hidden web? Now mind it, hidden web and deep web can be used interchangeably, but dark web is completely different. Yes, onion websites come under this category. So this hidden web and deep web, they both are similar to each other, but when I'm talking about dark web, it has a completely different meaning. So this hidden web actually was floated by Raghavan and Garsha Molina. They first coined this term, and they said that there is an enormous amount of information that is not publicly available but can be followed if we fill some form. Now if I talk about the the Aadhaar card information, that is available online. If I'll talk about IRCT database, that is available online. But can you get the information about my Aadhaar card or anyone's Aadhaar card without by just clicking on some links? No. What you need to do, you need to authorize yourself. You need to have a login strategy. Only after following or only after passing those form filling thing, only then you will be able to get that information. But that information is directly present over the World Wide Web, but even then it is not directly accessible to you, and that part of the web compromises hidden web. So deep web mostly consists uh, of data website or any part of the website that has some login page. Now these pages obviously cannot be directly accessible by any web browser. So what we need to do, we need to have some specialized type of web crawlers that can index them and can reach to the information that is typically hidden behind the web form. Now hidden web continues to grow because as the number of employees in any organization, as the number of things or data present online is getting increased, in the similar way the data which is present over the internet keep on getting increased. In the similar way, if I'll talk about that Arogya Setu app, the data that we are creating is hidden behind a web form. We can't directly get it, but if someone is able to pass through that login information, then you can get that information. In Chief Electoral Office web portal, some of the information are indirectly available. Anything that is available indirectly or that needs to tackle some of the, whenever you have to authorize yourself or you have to give your identification to access any information, even if you talk about Facebook, some of the data might be available publicly, but some of the information is available only to the person after he has passed that login process. That part, that login information that you have to pass cannot be done by any normal crawler. So what you need to do for that, you need to have a particular scenario or specialized type of crawler to get that information. Like this is one of the example. If I want to locate some of this store in the US, what I need to do, from the store drop down list, I need to choose some of the store. Then in the city, I need to fill up some of the city name. And again in state, I need to add some state zip number. Then this thing. Yeah, you need to. Tor is a web browser like Chrome, but DuckDuckGo is a search engine like Google where all the onion sites are registered. But have you tried to open any of the onion site? And is it because this DuckDuckGo, which you are talking about, is actually a search engine that is meant for dark web? There are, apart from DuckDuckGo, there are so many search engines which are meant only for the dark web, and their crawlers that they have designed are specially designed to to tackle these type of forms which I'm discussing now. If I'll talk about this particular form, like this store locator form, a normal web crawler will not be able to tackle this particular type of form because the content is hidden behind this HTML form and is not directly accessible. So what I need to do, I need to choose some of the values, and whenever I'll choose some value, what I'll get, I will get these things in the result. Now think this store. Now this store has a drop down list. That means this store has a finite domain, because this drop down list might contain, let us say 6, 7, 8, or let us say 1,000 values, but the domain is finite. In the similar way, this, if I have a radio button, now the radio button has 4, 5 things that I have to choose from. Again, the domain is finite. But whenever I'm talking about some text box, some paragraph, the information that can be entered in that particular element is infinite, right? So for that, what I need to do, I need to handle two things, two type of element: those elements in which the domain is finite and those elements in which the domain is infinite. And to control those things, I need to give power to my crawler so that it can handle those things. Now coming to the next slide, before coming to the hidden web crawlers, I need to tell you why we are so much interested in hidden web. Why, if we have surface web, why we are not satisfied with the data that is present over the surface web? The reason being, the information that is present over the deep web is around 500 times larger than publicly indexable web, or you can say the surface web. And the slide which I have shown you in the starting of my presentation, that this much information is present and all those things, those uh, that data is completely applicable, or that number is equally applicable on deep web as well. Now if the publicly indexable web is that huge, now think of the same thing which is 500 times larger, and 90% of the data that is present on the deep web is uh, publicly accessible. That is, you need not to give any fees or anything to access that particular um, uh, you know to access that particular information. No fees is present, so why not we just go and access that information? Yeah. Shakina, my PhD thesis work was also related to the deep web, because there is so much of information that is present over the internet that we don't want to leave that information. We always want to have that information, right? So that whenever, because uh, today if I'll talk about data science, if I talk about machine learning, all the things all the things are related to the data only. And as the data is the most crucial part these days, so what we want to have as much information or data that is present to us. That is the reason we are interested in hidden web. Right. So in hidden web, there can be two types of thing. There can be a dynamic web page. Dynamic web page means if you'll open your Amazon account, the things will be, placed according to your wish list or according to the things which you have visited in the past. And that content is getting generated on the go. So this is a dynamic web page. So whenever there is a dynamic web page that is getting generated on the go, that comes under the category of hidden web page. Now, this might happen that some of the content might be already present in the form of cookie at your end, and that might change the way any particular website looks like. So dynamic web page, indirectly accessible information, all come under the categories of hidden web. Now coming to the security aspects of the hidden web, now consider if I have a forum, I have a form that is present on any web page. Now any web page form can have some of the elements. Now I can model those elements as the element and the domain. Now this E and D will have two things. The elements are the particular elements that are present, and D is the corresponding domain that is present. Now, if I'll talk about selection list, text boxes, text area, checkbox, radio button, some of them might have finite domain, some of them might have infinite domain. And if I have any element that has a finite domain, it is very easy to handle those particular elements. But whenever I talk about any element whose domain is infinite, it becomes very difficult to model or to handle those particular elements. Reason being, if I have a drop down list, I can randomly choose any of the value. Right. If I have a radio button, I can randomly choose any of the option, and then my crawler can have a push button event, and then I can get the links that are present behind that particular form. But what if my web crawler has any element that has infinite domain? If it has infinite domain, then it needs to fill some of the particular value in that particular domain or particular box. And to fill that value in that particular box, it needs to know what is the meaning or what is the label of that particular box. And to know the label, to know the meaning of that particular label, we need to have a synonym list, because some might write person, some might write participant, some might write model or something. So we need to know those particular things. So this will be the generalized architecture for a Hive crawler. Hive means hidden web crawler. So what will happen here and how it is different from a normal web crawler? Now whenever you have a hidden uh, web page, what you need to do, your crawler manager need to identify that this web page is different from a normal crawler. Right. So when it has identified that this particular web page is a part of hidden web, what it needs to do, it needs to pass on that information to the form analyzer. And what is the meaning of the form analyzer? The form analyzer will check the elements that are present in that particular forms. Right. Now this, there might be multiple forms, there might be a single form. Let us suppose there is a single form. Now this form analyzer will analyze that form, and then it will pass on to that form processor. Now form processor will determine whether the domain of those form element is finite or infinite. Now let us suppose the domain is infinite. Now there will be an LVS manager. What is the meaning of LVS? LVS stand for labeled value set. where there will be some labels, there will be some values. Now if I'll talk about pin code, now the pin code, there will be a label in my form that you have to write pin code. Now there might be some synonym for that, like if there is name, there can be person name, there can be teacher's name or anything name. If I can specify, or my crawler can get that this form element, or my form processor to be more precise, can get that this particular label means this particular value that has to be filled. So I will have different labels that are possible, and from that labels I can get some of the possible values. So if I'm talking about, let us say, from the drop down list I have chosen Chandigarh. Now if I have chosen Chandigarh and in the next form element I am getting pin code, I know that the Chandigarh pin code starts from 16001 to to the number of sectors that are present in Chandigarh. Then I can randomly choose in the pin code any of the value set that is present here, right? And once I have chosen some of the value, again what the LVS manager will do, it will give the identified label and corresponding value. And when I have submitted or I have filled that form, what I'll get in the response, I will get some web pages in the backend. And for that I have a separate component known as response analyzer. Now mind it, whenever the LVS manager has filled the value, the values will be passed on back to the uh, form manager. So what this thing will do, this will choose some of the value. After choosing the value, this thing will be passed back to the form processor. Now this form processor needs to get the web pages that are hidden at the backend. And where those web pages are present, those web pages are present again in the World Wide Web. So this form processor, after submitting the form, will pass on the value again to the hidden web, from where it will get some of the responses. And those responses again will be sent back to the response analyzer. And what will be the function of the response analyzer? After getting the responses, what I will do, I will again update my labeled value set, right? So that, and if I have to fill another form, my response analyzer can get some of the names, can get some of the pin codes, can get some of the other elements in a better way. And this process will again update the values, labels and value set. And after this it will pass on those things to the indexer as well. The work of the indexer is the same. Now this response analyzer is working in a way which we call as action and response. In action and response, I am performing some action. And what action I am performing here? I am performing the action of filling of the form. And whenever I am filling the form, I am getting some of the links and web pages from the backend. And those web pages which I'm getting from as a response will again be used to update my LVS table. Now this will be again recursive approach that we will keep on following until and unless we can get maximum number of links that are present behind the web form. Now mind it, whenever you are using this hit and trial method of filling the form and getting the response from the backend, it's not possible that you will cover all the web pages that are present in the backend. You might get some of the web pages, and you have to you have to again keep on updating your query in such a way so that you can extract maximum number of web pages. Now if I'll talk about these things again in a better way, then there was an approach of mobile web crawling. In a normal crawling, what we are doing, we are my crawler is downloading all the web pages from server X and then bringing them to the local end, and again then indexing them and then discarding them. So there is an approach of mobile web crawling which have certain security issues related with it, but it makes the internet traffic very less. Reason being, what if instead of downloading each and every website over the World Wide Web and bringing it to the local end, what if I'll send my crawler to the server? It will go there, create an index of all the web pages there only, and bring the indexed information to the local end. Now what communication will happen? The only communication is that sending my crawler code to the server and then bringing the indexed web pages back to my, to my machine or to my local end. All the communication in between will be vanished, right? But but when we were doing normal crawling, what we were doing, we were sending the request for a web page. That request will reach to the server. The server will respond by sending the web page to the local machine. When it will get the web page, it will extract the URL. Those URLs again will be requested to the server. There was so many communication going on, and that is the reason there was so much of traffic over the internet. To reduce the traffic, we can use this mobile web crawling approach. But whenever you are using this mobile web crawling approach, there will be so many security issues. So let's discuss first this mobile web crawling approach. This mobile crawling approach means crawler code will migrate to the host sites where the web pages are located actually, and it is moving, code to the data instead of bringing the data to the code, right? We are bringing our code to the data instead of bringing the data to the code, and it can make our process very, very easy, right? So mobile crawlers are basically designed for this thing only. So this will ease the process. This is an interesting aspect, but it will also make the things, or you can, the security aspect related to this mobile crawling is quite different. Now, this will be one of the architecture that can be used whenever we are using mobile crawling technique. What are the things that are associated here? The things associated here are the communication subsystem, virtual system, again the scroller manager. Now think, whenever some third party code are coming to my server and it is getting executed at my end, now what it needs to do, it will be using my resources, it will be using my data, it will be using my web pages. Now how I can trust a third party which is sending some code to my server? So what I need to do, first of all, I need to be very sure from where the code is getting originated. The second thing, I need to provide a very, virtual environment to the code so that the code can access only those things which are permitted by me. Otherwise, it can do anything whenever it is coming to my end, right? So this server communication, all these things which needs to be tackled very effectively. So there are so many security issues. First thing, whenever you are executing the crawler, because the platform and the crawler from at the one server might be completely different from the another server, so you need to have your mobile crawler code in such a way that your platform is independent of the execution environment. The second thing is, because you will be running your code in a virtual environment, your code should be smart enough to change itself depending upon the virtual environment that the server is providing to you. And then there will be a communication layer that will be established whenever your code will reach to the third end. So you need to have that communication layer transport protocol in such a way so that effective communication might happen, right? In the similar way, because it will not give you endless amount of information or time to get execute its code, to execute yourself in the server end. So you need to handle those things of database connectivity again in a very rapid manner. Now, whenever I talk about how good a search engine is, there are some things which we need to discuss. First thing is the effectiveness, efficiency, and cost. So, effectiveness means the ability of any search engine to find the right information. If I have shooted a query, how easily I can find that information, that is the effectiveness. Efficiency means when I am finding some information, how quickly I am getting that information. And then cost means what are the processor, memory, disk, and networking costs that was involved in getting that information. So I will be quickly coming to this recall and precision, because these are the things that are used again and again whenever you are talking about any of the web crawler. So let us suppose quickly that this box represent all the data that I have indexed. And then after doing the indexing, what I have done, I have shooted a query, let us suppose. Now, if I have shooted a query, what I will do, I will type the query and then I'll press that, go and find the information and I will get some of the result. Now, think that I have shooted, let us say I have typed, um, let us suppose data science. When if I have typed data science, let us suppose these green circle represent all the items that were present, that were indexed, that were related to the data science. But your query was not in such a way that it can give you all the results that were related to data science, and it has given you these results that were represented in the this orange circle, or you can say this pink circle. So green represents set of the relevant items that were present in the database as per your query. Orange represents set of the items that were retrieved after shooting the query. Now, if I'll try to divide it, I can divide them as these are the, this intersection represent the relevant item that were retrieved after my query. This part represent the relevant item that were not retrieved but that were present in the database. This orange section represent the irrelevant items that were, or the noise that were retrieved after shooting the query. Now, if I'll talk about the names, I can name this thing as the A and this thing as the B. Now, if I'll talk about recall, recall is actually the ratio of the number of relevant items that I have retrieved divided by the total number of relevant items that were present in the database. So recall will be A, that is these are the items that I have retrieved, divided by A plus B, that is the relevant items that I have retrieved. Now coming to the precision, precision will be the ratio of A divided by A plus C. That is all the relevant item that I have retrieved divided by the total number of relevant as well as relevant record that has been retrieved. So what you will try to do? You will try to improve your precision as well as your recall, but there is a trade-off. Whenever you will try to increase your precision, you will use some of your recall and vice versa. So you need to be very sure whether you want to have a high recall system or you want to have a high, you know, uh, precision system. So you need to determine whether what you want to do, right? So now Aman ma'am has asked me to stop at 1:05 because there is some test or something that she needs to conduct. So I will stop here. So if you have any query, you can please do ask me. Any queries?
Participants, if you have any query, you can post in the chat box. Yes, there is one, I guess.
Yeah, this recall and precision are used in AI ML, and whenever there is some data that involves any of the data, let it be, data from the crawling or data from the AI or machine learning algorithm, these precision and recall are used as effectiveness matrices in all the models. Any good book to add in syllabus? The good book I can suggest for this thing is by Somen Chakrabarti. You can search. He is from IIT Bombay. He has a book in this crawling and everything from Somen Chakrabarti. Deep web and dark web, no, they are not same. Dark web is the part of the deep web where all the illegal activities are happening. So other things are related to, I think, Aman ma'am. What is the time? What is the exam link? What is the course code? So thank you. Thanks for your patience.
Thank you so much, Manish sir, for sharing such a elaborative session and sharing the intricacy of the web crawlers. And we really want to thank you again for the session.
Thank you.
Okay, participants. Okay, you may share your feedback about the session. There is no need to hurry. I'll post the link and I'll give you enough time for the quiz.
morning, madam.
Good morning, sir.
This is
I think it's
Vemanachari.
afternoon. Yes, sir. Please.
This is Vemanachari from Hyderabad, madam.
Right, sir.
So, so from basic to you have given some application to the what is cyber security. So how can we avoid the cyber security in mobile, in Android operating system level? And now last sessions also how the formulations and regulations, what are the cyber security laws designed by our constitution. So now you difference between last sorry as children we have get lot of information from cyber security, madam. So same
Thank you
thing we
so much,
can
sir.
pass to our students, madam. Thank you, madam.
Thank you. Thank you so much, sir. That was our ultimate objective. So,
Okay.
okay, participants, I have one announcement to make that at 3:15 p.m. we want to record the feedback from you. Like we want some 4 or 5 volunteers. Actually, we have to send this recorded feedback to AICT. So it will not be possible to record for everyone. So I would request some 4 or 5 people if they can prepare a 5-minute speech and we can record you and we can share that live with AICT and it will be posted on YouTube as well. So after the quiz, you can give me your names. So we will announce your names at 3:15. From 3:15 onwards, we'll start the recording. I will announce your names and accordingly you can come and you can speak for 5 minutes. So I hope it's clear to you. Now we'll be starting with our quiz. So regarding the quiz, there were a lot of questions. It will be consisting of 15 questions and you will be having 30 minutes for the same. And after 30 minutes, if I receive any responses after 30 minutes, I'll be discarding those. So you have strictly 30 minutes for the same. Uh, I'll be sharing the link now. Just give me a minute.
Hello, ma'am.
Hello. Yes, ma'am.
Ma'am, will you please again elaborate upon regarding the examination?
Regarding the examination, I'm just saying that it will be of 15 marks. There will be 15 questions, 15 marks, and there will be 30 minutes will be given to you for to complete it. And if you are like submitting after 30 minutes, then it will not be taken into consideration.
Okay, ma'am. Thank you.
Okay, so I have forwarded the link. I hope every participant is able to
Negative
find the
marks
link.
will be there.
No, there will be no negative marks. You don't have to worry about anything like that. So the starting
Okay,
time
ma'am.
for the
Thank you.
quiz, I'll be counting from 1:15 and you'll have time till 1:45. So if I receive any response after 1:45, I will discard that. So you have time till 1:45. You can submit it before that. Thank you. I've pasted the link again if you have not found it.